For my birthday, I bought myself a copy of this book by John Conway called Regular Algebra and Finite Machines, which I never read. I didn't even know about until after I got to Bolivia. And it's a great book. It's about a theory developed by a guy called Moore about Moore machines. And Moore machines are a bit more than an ordinary regular automata, because Moore machines have input states or have state sets which correspond to output symbols. So a Moore machine not only recognizes input strings with recognized, not recognized, it actually classifies them any old how, but to some degree you can reduce the theory to just accepting or rejecting certain words from a language. And by words I just mean strings of symbols on an alphabet, and by a language I just mean the set of all possible strings from an alphabet. But it's a really good book. And it started from a course that he gave at Cambridge in 1966. And so I was thinking about blinking LEDs and pi picos. And to make a nice blinking LED, there are a lot of different ways an LED can blink. You can do the full PWM, so the blinking LED is really one-dimensional computer graphics. And you want a language that will express all the different kinds of ways that LEDs can blink. And if you think of a one-dimensional movie, which is one-dimensional computer graphics with sound, I can hook up my headphones and my microphone to this Pi Pico and use them as signal sources, use them as the interface. And we're extending the movie analogy a bit, but it's been done before. Because this Pi Pico has got analog to digital conversion on it. So it can listen to the microphone and it can produce digital to analog converters are easy enough to produce, and you can also just apply a low pass filter to PWM output, and you can get very nice audio from just a single digital binary output with a sufficiently precise time domain. So that makes a whole... I was writing yesterday about how I wanted to try and use meta languages, try and use languages as the user interface for programs running on this chip, so that you control the machine's responses to its inputs are the result of the programs that you download to it. But you really just, in this case now, I've kind of dropped that idea, because I'm now talking about making machines which are automata that their structure is not altered from outside. But you could add that as another dimension. And you get to, there's lots of material in this regular algebra and finite machines book that applies to observability and experiments on machines by other machines. And you can, there's a whole field of mathematics connected to chaos theory called symbolic dynamics, where you take a dynamical system, which is an analog set of relations between sort of response, closed loop stimuli response systems, things like the Lorentz attractor, which you can implement with electronic components as an analog computer. There've been several nice YouTube videos of people doing this, and they actually make really interesting sounds, those systems. Symbolic dynamics treats those systems as sources of symbols, streams of symbols, by just doing a very crude partitioning, saying, is it above this threshold or is it below this threshold? Which dimension of the system is above and below certain digital thresholds chooses the output symbols, and you output a symbol on every transition from one of these gross quotients of the state space of the dynamical system. So you quotient that space by some discrete space and use it as a source of symbols. And you get chaotic systems which have a kind of language. There are certain characteristics. You can study the frequency of the occurrences of what are really events in these analog systems. And I haven't seen any, but I haven't heard of any research, but I'm sure somebody's done it, how these systems could actually adapt and respond to each other, and probably there are probably ways to connect two Lorentz attractors together by some signal path which allows them to perturb each other, and then you can study the outputs, and you can probably see how changing that connection, how the machines independently adapt to changes in their environment, which is affecting the way that they talk to each other. So yeah, this PyPico thing is good fun. But my God, it's complicated. So here's my notes. And here's the beast. And that's my Malaysian table. They have some very good wood lamination techniques in Malaysia. Look, it's quite a nice table. It cost me £20 from there. I use the RSPCA shop in Canton. So there we go, that's my video this morning. Having fun.